Hey, Math 098, we're going to continue Chapter 9 with Section 5, log functions. What we're going to get at is that log functions is just an operation. And more specifically, it's an operation that undoes exponents. That's what it means to be the inverse of an exponential function. So what that means, maybe what I should do is first give the keywords. We call this log, it's short for logarithm, logarithmic, where we call the small number right here the base. There's a reason for it. So it's log base 2 of, whatever this number, we use of that number, is equal to whatever that other number is. So as you look at some of these problems, if I ask you to change it to exponential, at least for the first couple problems, I think it's pretty clear that we can change this because the key word here is base 5, log base 5, that it's 5 to the second power is equal to 25. Now, I've also seen teachers will, instead of teaching this as log base, that's what the word is, what they tend to do is let me change colors. They put like a shoe type thing around here where they write it as a small number, 5 to the second power is equal to 25. And for right now, it shouldn't make perfect sense because it's true that 5 squared equals 25, but down the road, we're going to get to more complicated things. So if we follow that same pattern with the base, 6 to the negative first power is equal to this number, 1/6. That's absolutely true. Same thing with the next one. If I were to make now this is based off of the program I use to write out these problems, that sometimes this small number looks like it's part of something else. But if you remember from earlier, in an earlier chapter, we learned that something to the fraction exponent becomes the root of that number. So this is true, that 2 to the 1/2 power is equal to the square root of 2. So why do I want you to practice that? Well, when we get to the next one, we don't have a number here to do this, but we can solve for x. So this might be a future problem where it asks you to solve for the variable. And what you would do is say, okay, well, 7 to the 5th power is equal to x, based off of that boot method, if you prefer that. Otherwise, you can say, well, it's log base 7. So in exponential form, 7 is the base. 2 to the 5th power is equal to x. Well, now you can solve for it, because you can do 7 to the 5th power. Okay, 16,807. So if you have your calculator, you can actually figure out what x would be. But in the context of this question, all they wanted you to do is stop right there. But I'm just giving you a heads up on where we're going with this. So in the same light, I could ask you to go backwards, where I give you the exponential function equation and ask for the logarithmic equation. And some people write, like my teachers always wrote in cursive, so you might see me write in cursive, but I might also write in print. The base is still 4. So it's log base 4. The equals number that's all the way over here is the 3, if you've seen the boot that I'm talking about. So it's log base 4 of 64 is equal to 3. And since I started with the calculator, I might as well show you right here that while it's true that 4 cubed is equal to 64, that's a true statement, under my math tool, if I scroll down for a while, I actually have this button that says log base, and I can double check that I'm doing this correctly. If I wrote out log base 4 of 64, look at that, it equals 3. That's exactly what I wrote down, log base 4 of 64 equals 3. So I'm not showing that to you to have you cheat. I'm just showing it to you to try to help you out, I guess. So as I look at the next one, the base is 6. So log base 6. If you made a boot, it would be the 1/3 power would be over here, and then I'll go ahead and make the boot. I don't know if you can see the shoe there, like there's shoestrings right here. I don't know. That's kind of a lame. Is equal, well, the equal number is what we put right there, the cube root of 6. Cube root of 6. Same thing with the next one. We have log base 5. Notice that the 5 is the base in that exponential form. The -3 goes over here if you made a boot, and then is equal to 1 over 125. So if you made the boot, you can see it, and then go backwards. So then we just have one more problem, kind of changing it up, because we can have any base that we want. Typically we have positive numbers for our base. The 7th power would be over here, and then the z goes right there. So a lot of practice will be helpful for you. And the reason why we go through that process is so then when we get to this part, because not a lot of students are good with logs. I get that. But what might be helpful is if you set this equal to some variable. Let's call it, let's see, b is usually used for the base, so maybe I'll call this a. So if you go from log form to exponential form, it makes perfect sense that you do 3 to the a power is equal to 9. Notice my boot there. So log base 3 of 9 is basically asking 3 to what power gives me 9? And that answer would be 2. 3 squared gives me 9. Now, I am well aware that I just showed you how to use a graphing calculator. And again, it's under the math tool. Log base, what was it, 3 of 9. And it does spit out the correct answer. You know, I'm not stupid. I know that these things work. But I do want you to understand the underlying theme. And I want you to understand why the answer is 2. Well, if you can answer that and you can say, well, 3 squared equals 9, then I think this is worth you using. You know, same thing goes with the next one. Just slightly change colors. Let's just use a different variable. I don't know, k. You know, just a different variable. So if you change this to exponential form, you would say 2 to the k power is equal to 1/8. And if you remember from the previous unit, I asked you to practice getting the same base. Well, 8 is the same thing as 2 cubed, but to make it 1/8, it would be negative. So 2 to the -3rd power is 1/8. So the correct answer is -3. But again, I'm well aware that if you use a calculator and you hit that math button, and it's actually faster if you hit the up a few times. Log base 2 of, let me make a fraction, 1/8. I'm well aware that that spits out the correct answer for you. And then just for the sake of practice, whoops, I don't know what I just did there. Sorry about that. For the sake of practice for this last one, I'll go ahead and call this y. I know that might be confusing, but that's commonly used. Whoops. So our base is 49 to the y power is equal to 7. Well, it might make sense to use the common base of 7. 7 to the first power is 7, and 7 squared is 49. So it makes sense that we can now set those exponents equal to each other like we did in the previous lesson, and then divide 2 over, so the correct answer is 1/2. And again, I'm aware that you can use a calculator and type in log base 49 of 7, and it will give you the correct answer, 1/2. You might have to hit the math fraction key, but it is 1/2. And then just a few more problems, trying to get you to think a little bit. So trying to keep this video somewhat short, but changing to exponential form is your friend. So we're solving each equation for x. And I know some people just guess and check as well. I do realize that that's an option for some students. For instance, to make it a fraction, we're going to take it to a negative power, and 5 squared must be 25, and therefore x equals negative 2. So feel free to check your work using a graphing calculator. So on the next one, notice that x can be a base. Okay, so that's why you really need to understand this, because if you change this to exponential form, x to the third power is equal to 8, you might struggle a little bit, but if you then solve a cube problem by cube rooting or taking to the 1/3 power, and that's why this works, is that the third and the 1/3 cancel, and we're left with x on the left side, and 8 to the 1/3 power would give you 2. But guessing and checking is a viable option for you. As I look at the next one, changing to exponential form, be 6 is your base. 2 to the second power is equal to x. Well, that's pretty easy. 6 squared is 36. So that must be what x equals. Okay. And by the way, if I'm going too fast, please, please, please write down your questions. Let me know, what you're coming up with. So in this next problem, we're kind of trying to come up with a rule here, because some students tend to forget that there is a possibility, 13 to a power to give us 1. And I'll just go ahead and give you this answer away. There's only one possible answer, and that's if the exponent is equal to 0. It doesn't matter what the base is. If we have h to a certain power is equal to 1, then x must be equal to 0. Now there's a little caveat in here. We want to make sure we have positive bases. And one more thing that I want to mention, this is pretty important, is we can only log, and it doesn't matter what the base is, I'll log base b, positive numbers. We cannot even log a negative, or we can't even log 0. And you could try it with a graphing calculator. Just hit log, doesn't matter what the base is, type in 0, and you get a domain error. So that is very important that you realize we can only log positive numbers. So as we move forward to some properties, notice that, as I mentioned before, logs and exponents undo each other. Logs and exponents. They're inverse operations, so they have to undo each other. Just like multiplication and division undo each other, that's our inverse operation. Addition and subtraction are their inverse operations. And we just talked about this. Log base b of 1 is always equal to 0. Whereas if the bases are the same, they cancel out and you're just left with x. If the bases are the same, they cancel out and you're just left with x. So I'm not trying to rush through this, but I think I can fully explain this right now. See how the bases are the same? So this answer is just 4. See how the bases are the same? So the answer is just -2. And this is the other way of writing it. Is 6 to the log base 6 power. They still undo each other, and the answer is 5. Same thing with this last one here. The bases are the same, so they undo each other, and the answer is just 4. But make sure that you're only logging positive numbers. Okay, that is very, very important. And then my last example is getting you to graph. And as I mentioned, we can only log positive numbers. So that's why we only have answers that are to the right. And the other piece I want to mention is that the x-intercept will be 1, 0. And again, I'm not trying to just rush through this, but it's the inverse of exponential. So it almost looks like an exponential function, except it's reflected over that line y equals x. So it's a exponential function, b to the x reflected. I'm going to have to make a second video. I'll see you then. I want to explain this better.